got any questions up for us? So can someone raise your hand and tell me, what is the question asking you to find? Asking us to find. Joseph?
Alright, so the question asking us to find, well, the information that's given to us is determine the density of the objects.
Fantastic. So Joseph just read from the question, determine the density of the objects. We just took that directly from the information given. And what did we learn was the formula for density? DEMA. What is D equals heart all about? What does that mean? So DEMA remembers that you get your heart broken every time you fall in love, and when you get your heart broken, you get mass with the volume.
Yup, it's true.
In some weird way, yeah.
Absolutely.
Okay, so we have, so then in order to calculate density, we need two things. What's one of them? Mass. Faith. What's the other? So mass and volume. Great. So we need to find mass and volume to find density, which is what the problem is asking us to find. Okay? Question number 2. What information is given to me? So we need to find mass, and we need to find volume. Do we have any information on mass from the information given to me? Juanita?
The relation is that it's doing like the physical property.
With regards to mass, is there any information about mass? Someone have it? Why? Okay, Brianna, you want to help out Juanita?
Yes, it says determine the mass to be 30 grams.
Okay, so Brianna just took some information that was given to us in the question. Can you read it one more time?
It said determine the mass to be 30 grams.
So the mass is determined to be 30 grams.
Right.
Jocelyn, where did Brianna get that information from?
Question.
From the question. This was given to us. So we're trying to find density. We know we need mass, we need volume. They gave us mass. Okay. Derek, how do we get volume?
Volume, just check the length and width and height, and it gives you the information in the picture.
Awesome. Derek is saying to calculate volume, we need length times width times height, and then he looks straight to the picture and he's like, oh, we have length, we have width, and we have height. So we don't have volume yet, but we can go find volume. Yes, Justin? Okay, so does that mean we have to multiply 3 times 2?
Yes.
Yes. But we also have to multiply,
7.
so volume is equal to, what's 7 times 3?
21, I mean.
Times 2?
42.
Am I done?
No.
What am I forgetting?
You're forgetting your terms.
Someone raise your hand and tell me what I'm forgetting.
21.
So what am I forgetting? Lucas? Centimeters? I was forgetting centimeters, yes. What else am I forgetting? That's part 1. Wait, what 3? Centimeters cubed. That 3 is cubed. Great. So we just found volume. David, do we have everything we need to find density now? Yes. What do we need to calculate density? Back to our broken heart. Volume's one thing. Dima, what's the second thing? Mass? Okay. Do we have mass and volume now?
Yes.
Yes.
No.
David, do we have mass and volume? Where did we get 30 grams from? The what? Lucas, where did we get 30 grams from?
Oh.
Valerie, where did we get 30 grams from? Yes, 30 grams is the mass. Where did we get that information from? Derek, help?
Is it a question?
From the question. If you look down at your question, look down at your paragraph, the initial question, it tells you. So David, where did we get 30 grams from? The question. So do we have mass?
Yes.
Yes. Do we have volume?
Yes.
Where's volume? We just calculated volume.
That's right there.
Tristan, the formula for volume was? The formula. Okay. So then do we have all the pieces we need for density?
No. Yes.
Yes. We'll just plug it into our formula. We got mass. Mass, we got from the question. They gave us mass. Volume, we just calculated volume. We had to go find that. But we did. So without doing anything, we're just plugging it in where they belong. And we get density equals 30 grams over 42 centimeters cubed. So this is correct. Can we reduce this, or can we simplify this further?
Yeah.
Can we? What do you think?
No.
Can we divide each of these by 2? One second. Brianna?
I say 6.
She says 6. You say 6 fit into both of them.
Because 30 divided by 6 is 5, and then 42 divided by 6 is 7.
Okay. These two answers are what we're looking for. This is what we want to be. We'll get there. Joe, ask me first. Yes, Derek.
That 5 seconds, I see 3 centimeters on the picture and 2 centimeters would equal 5, and then that's the 7 right there.
I see. That's not the right way to do it, though.
But
That was just lucky. Just by chance that those numbers added up to that and the 7 was there. Okay, so then, does everybody have this written down?
Yes, sir.
in the second part of your question. This is something we haven't worked on yet. Now that we've calculated density, and I'll just leave it over here for reference. We got density was 5/7 grams centimeters cubed. The question then is, will the unknown object sink or float in water? So will that cube sink or float in water? What do we think?
I think it's gonna float.
What's the density of water? Let's take 60 seconds and see if we can recall what the density of water is. So as we chat with our partner, I'll check back in 60 seconds. IHCP in 3, 2. Do we remember the density of water? Justin? Yeah. Okay, we're looking for a number. Kind of like the boiling point of water is what? When does water boil? At what temperature? 100 what? 100 degrees Celsius. Fantastic. So, what's the density of water? We're looking for a number like that. Royalty? Per what? Royalty got half the question correct. Density of water is 1 gram per centimeters cubed. Okay, so then the question we should be asking ourselves now is this object that is 5/7, 5 grams over 7 centimeters cubed, going to sink or float in water? Is 5/7 greater than or less than 1? What do we think? David, is 5/7 less than or greater than 1? He's thinking it's less. Who agrees and thinks it's less? If you had an exam and there were 7 questions and you only got 5 out of 7, did you get 100%? Did you get the whole thing right? So is it 5/7 less than or greater than 1?
You guys, 5 out of 7 is the same thing, 5/7. 5/7 is what? What is this called? Just over in math, what do we call it? A fraction. A fraction is less than a whole. What is the whole? How would you make this into a whole? Raise your hands. 3 students have their hands up. How would you make the 5 students? How would I make this into a whole? It would be what?
The same number as the non-denominator.
Yes, which is?
Which is 7.
7 over 7, or known as 7/7. So 5/7 is greater than or less than 1.
Less than.
Raise your hand. 5/7 is greater or less than 1. I should have more hands at this point. Yes, Jocelyn?
Less than?
It's less than.
All right. 5/7 is less than 1. Someone said. So, royalty helped us out, so the density of water is 1 gram per centimeters cubed. We just found the density of this new unknown substance, and we find out that its density is less than 1, which is less than the density of water. So is it going to sink or float? Talk with your partners, I'll come back to that. More or less. The density of water is IHCP 3, 2, 1. Good sir. What are we thinking? Is it going to sink or float? Okay, how are we going to answer this question? There's a format here we have not discussed yet, and you should be writing this down on your paper. We have claim, evidence, and reasoning. What is that all about? All of a sudden I'm like mixing science, math, and English writing on you. What is going on? I know, right? It's like, this is the worst nightmare. You come here looking to have fun and it doesn't happen. So, will the unknown object sink or float? We're going to use a specific format to answer this question. Claim, evidence, and reasoning. So we'll start with the claim. You should be writing this down. We're going to start with the claim. Somebody make a claim.
Sorry, did we just write C?
Justin,
All right.
I want to hear what you have to say. I've asked you before. Yeah, just raise your hand, and I got you. So, somebody make a claim. Is this going to sink or float? Faith. Okay, so complete sentence.
The object is going to float.
Here's Faith's claim. Faith makes a claim. The object, the unknown object, will float. That is Faith's claim. That's great. Anybody could have a claim. You could have a claim, you could have a claim, but you gotta have evidence to support your claim. So what evidence do we have to support Faith's claim that the object will float? Let's think here. We have all the evidence we need. We already did all the legwork. Now it's just using the information that we have. What's the density of water? Dina? Density of water? One what? Yes, cube. The word is
Cube.
so put it all together, Dina. Per centimeter cubed. One more time.
1 gram per centimeter.
Fantastic. Okay, yes. The density, as Dima just pointed out, for water is 1 gram per centimeter cubed. The density for our object, Joseph, is what? What's the density for our unknown object?
Unknown object is 5, 7 grams and 5 to 7 grams centimeters.
Cube.
Yeah, you're right, per centimeters cubed. 5/7 gram per centimeters cubed. Absolutely. And we just discovered that 5/7 is less than 1. So we're going to go into why these things float in a second. The evidence you're going to use, because faith is correct, I'm going to tell you right now, the object will float. What evidence do we have? The density of the unknown object is less than the density of water. How do we know that the density of the unknown object is less than the density of water? Because we wrote it down. Because the density of water is 1. And we found the density is 5/7. And any fraction is less than 1. Sorry. So faith made a claim. The object will float. Our evidence? The density of the unknown object is less than the density of water. We calculated, we did the math. For our reasoning, the final part. Were you just working on transitions? Were you just working on transitions and catalysts? Therefore, because the density of the unknown object is less than the density of water, the unknown object will float due to its lower density. So when I come around, I should see this written down on your paper. Well, Sienna, have you written it down? Can you sit closer to the board? Yeah. Noted. Royalty's got it, Joseph's got it. Yes, sir. Mike, yes. You're gonna use this for your homework, so don't, so. What?
This gonna help us. He just said something.
Okay. On to today's lesson then. Here we go. Again, people, young minds, young scholars, y'all, when you get a word problem, you should be asking yourself these questions. What is the question asking you to find? What information is already given to me? Always, 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 just jot down the information that they already gave you. Make your life easy. Then, what information am I missing? So, welcome to class. What? And for the word of the day, I love this word because it's just funny to say. Word of the day is funny to say. Poppycock. Definition. Nonsense. The argument you presented was loaded with poppycock. AKA, what you just said was a bunch of, you know what. Yeah. Poppycock. Nonsense. Okay. Glad you enjoyed that. So for today we're going to really find out. Oh, wait. So today we're really going to find out why that 5/7, why that object floated in water. So, Derek, what's our objective for today?
Write down the word.
Yes, sir.
Density of liquids.
What about the density?
WVAT. Calculate the density of
Students will be able to calculate density.
Be able to calculate the density of liquids.
I would ask me first. Observe. We got some things here. We got vegetable, water, fish, soap, corn syrup, honey. This water you'll notice is red.
You mentioned what it's liquid.
Food color.
Is that a real picture?
This is a real picture.
I tried that one. We can try that.
Okay. We'll get back to that picture. Before we begin, you may now flip open your science journals to the next page of notes. Actually, no. Back instruction. My apologies. That was me. Take one test down. There's a line going the rest of it. Take one test down. Hold on. Some of these lines. Raise your hand if you don't have a sheet. Okay. You have to do your best for today, and then I'll see if I can switch you over to a different seat. So this sheet will be turned in. You're going to keep the exit ticket sheet that's going to assist you with homework this week. This sheet, I need 100% eyes. I need 100% of eyes. Otherwise, we're going to miss this important instruction. I'll wait till I have 100% of eyes. This sheet will be turned in at the end of class. So, you're filling this out as we go along. Number 1, you'll notice says volume is. Volume is how much space something takes up. And as Derek just said, The formula for volume is length times width times height.
So, but you said I'm
You have a sheet in front of you that says volume is blank. You're writing down what is on the, okay, so volume measures space. I'm just paraphrasing, I'm summarizing. How much space something takes up. That's volume?
No. So, how much space it takes, so that's mass. I mean, that's density.
Joseph. You write it down? No, that's the formula. You're right, that is the formula. But look. This should be written down on your sheet. This should be written down on your sheet. Volume is how much space something takes up. Mass. What's the tool that we use to measure mass, David? Triple beam balance. Yes. Okay. A triple beam balance is a scale. It's just a certain type of scale. So we have our triple beam balance, and it measures mass. And in what units do we measure mass in? Lucas? What units do we use to measure mass? Measure mass on triple beam balance. Yeah, what units though? Is it pounds? Huh? He says grams. Yes.